All right, so I'm going to make a video. This is just going over every question from this multiple choice exam, so all 40 questions. And so if you missed, on Schoology it says which ones you missed, and so you can just go through and skip forward in this video if you need to. But I'm going to go through just like the general, like what's on the test and everything, and how the scoring works and all that. So with the AP test, it is 50% multiple choice, 50% free response. And so the multiple choice, there's 40 questions, and you multiply it by this number, and then you add it to the free response, which is calculated a different way, but it comes out to 50-50 scoring. And so here is the scoring range that you need to be in. And so 3, 4, and 5 is passing. And so this was for 2018. So if you got a score of 37 or above, you were passing the AP test. So the multiple choice, I think, is generally easier to get credit on than the free response, because you can guess. The free response is very picky, and like getting a 2 or 1 is pretty hard. Hey Blake, what's up?
I was going to ask if I can get my report card.
I don't have it right now, but I'm gonna get it later.
Okay.
Yeah. Okay, so the free response, like, it's just a lot harder to get credit on, but like multiple choice, this is like what you're shooting for to get a 3, 4, 5. So like just look at what you did on the multiple choice, how you scored, and the thing about it too is we haven't done a whole lot of review, and so it's kind of like a part of taking a bunch of mock exams is to get a feel for what the test is like and what you are struggling on. And so another thing I'm going to release eventually is this multiple choice exam key. And so what it does is it goes through, like, number 1 was this topic, and this % of people got it correct that year. And so if you were struggling, it just shows like who else was struggling too. So like number 4, a lot of people were getting right, but number 5, like nobody got right that year. So it kind of lets you compare yourself versus average as well. And so, yeah, and then another thing is on AP Classroom. So all these videos, like if you see that you're struggling with a certain unit, all these videos, these daily videos, are just 5 to 8 minute videos over the entire year, and they have questions to go with them. And so every single unit has these videos for you to look at. So if you're really wanting to pass this AP test, these videos are like the key to reviewing the entire year. They literally go through the entire year. And then at the end, if you click review, these AP daily videos, it takes you to the YouTube. And on YouTube, we've got an AP statistics, and they're going to be doing these like review videos. They're going to do like 9 or 10 of them, and they can also teach you like overview. These are like more general review, but on AP Classroom, these little daily videos go by unit, topic by topic. If you're struggling, like you can look back at these. And so like with limited time in class, I can't do this in depth, and so you have all the time to like look at these whenever you're ready to look at them and see, like, I need help on probability, so unit 4 probability, and I'll look at all these if you need help. Okay, so what I'm going to do is I am going to go through each one of these. Again, if you need to skip forward, like you don't know how to do question 1, 10, and 40, then just look at those. But I'm going to do this. It'll probably be a decently long video and go through each question. Okay. All right, so let's just go for it. Okay, so on this first problem, it says we've got a histogram, and it says there were 100 people asked, and then here's this histogram showing it. So based on the histogram, what is the IQR of prices? So interquartile range is the Q3 minus the Q1. So Q3 is like the 75th percentile and Q1's the 25th percentile. And so since we have exactly 100 people, this is basically what's the 75th person, what's the 25th person. So what you're gonna do is I can count like these tops and see like where is the like 25th number. And so 8 plus 13 is 21. So that means the 25th person is somewhere like in this range. The, what would that be? Like the $9 to $11 range. And then the Q3, 75, so I'm gonna go 2, 3, 8, 16, 16 plus 8 is what? 16 plus 8 is 24. So that means we're somewhere in here if I'm looking for that 25th number. So somewhere in there is the $15 to $17 range. So the distance between these two, 15 to 9, 17 to 11, is about somewhere between about $6. And so that's too little, too little. I don't really see a $10 difference, so I'm gonna go with this like 5 would be the answer. So then that's like my IQR, $5 difference. What's the difference between here to here? It's about $5. All right. So that's number 1. Number 2. Okay, number 2 is a little tricky. And you can see from the key, like I think it was like 30% of people got this right. But suppose you have a certain scale that's not calibrated correctly. As a result, the mass of any object displays is 0.7 kilograms less than its actual mass. So what this actually would do is like I've got my actual kilograms and my displayed. And so what it means is like, let's say I actually have an object that is like 4 kilograms. It would be displayed over here as 3.25. And let's say I had another one that was 5 kilograms. It would actually, so if I had a 5 kilogram, it would actually be over here displayed at 4.25. Okay, so the question is, what's the correlation between the actual and the displayed? So what's the correlation? So correlation is this R value, so like how well does it fit? And so correlation is saying like, is it positive or negative, and how strong is it related? And so like if I had like a 6, a 7, an 8, so like 6 would be here because it would be 5.25. So what actually happens is this is actually like a perfect straight line because every single one of these is an exact 0.75 off. And so this is like a perfectly positive number. And so that's where R equals 1. So it's like perfectly positive correlation. It's just off, like it's off, every single one of them is off by 0.75. So since every single one of them's off by a certain thing, but they're perfectly off, they're like a perfect line, R equals positive 1. That's number 2. Okay, number 3. What we have is some information, and it's like a two-way table. I've got like cat or dog, are they healthy, underweight, overweight? So based on the data table, which of the following is the most appropriate type of graph to show if there's a relationship between two categorical things? So I've got a category of like pet and a category of healthy, underweight, overweight. Okay, so let's just think about this. So stem plot, a stem plot is where it would be like 0, 1, 2, 3, and there would be like the number 54 would be like, I don't know, 5, 4. So this is not, a stem plot is for like numerical data, quantitative data, and this is categories. So this is not, I want to look for categorical stuff. Scatter plot is also quantitative, like numerical, so number data. This is categorical. So I want categorical data. Okay, side-by-side box plot. So box plots do the IQR and the minimum and the maximum. There is no minimum maximum on this. So again, this is not numerical data, it's categorical. Same thing with dot plot, that's like numerical. So segmented bar chart is like the only thing that graphs categorical data here. And what those are would be like the thing where we did these. And let's say that like healthy is red. So a cat would be like 300, a dog would be like 299 or whatever. And then you could have like underweight would be here, underweight here, and then like overweight versus dog. It would be something like this, which this is the categorical graph. All these others are numerical, like quantitative stuff. So just which type of graphs fit what type of data is what this is. Okay. So number 4. All right, number 4 is sampling. And so what we have, a program exists to encourage middle school students to major in math and science. The organizers want to estimate the proportion of students who, after completing the program, go on to major in math and science. The organizers will select a sample of students from a list of students who completed the program. Which of the following sample method describes stratified? So how could I do a stratified random sample? So remember, stratified is when you split into homogeneous groups and then you sample from each group. So like in this case, if I'm going to split, I'm probably splitting into like male and female, and then I'm going to sample from each. And like this is my sample, a sample from each. So stratified, select a sample of students. Nope. Randomly select 50 students. Nope. Randomize the name, select every 10th student. That is called systematic. So not this one. Select 25 names from females and randomly select 25 from males. That looked pretty good. Randomly select 50 students. No. So it would be D. Stratified is when I specifically pick from, I split into like juniors, seniors, freshmen, sophomores, then I go from there. In this case, what we did is like I randomly select some, I make sure to get some females, some males, I get some from each. Okay, so D. Okay, number 5, you could see on the key that I think it was 8% of people got this correct because it's tricky. It has a little trick here. It makes it look like it's super easy, but it's actually not. So this says that this is a normal curve representing the sampling distribution of a sample mean, size 25, and selected. So which of the following is the standard deviation of the population? So what would be the standard deviation of the population? This graph is a graph of my samples. So if we looked at the formula chart, it would say the population standard deviation equals the sample standard deviation divided by the square root of n. So this one's specifically asking for the population standard deviation. This is my sample, and if I was to get like a sample standard deviation, I would probably choose like my sample standard deviation would be 15. So this right there, most people chose that as their answer immediately, 15. But this number right here, I wanted to know this. So what you have to do is it was actually 15 divided by the square root of 25, which is 15 divided by 5. So it was actually 3. 15 divided by 5 is 3. So this A was actually the correct answer. C is the most commonly put question. And it was because the words, like we wanted the population one, and this was a graph of the samples. So we had to convert it. So it was actually a really tricky one. Okay, number 6. So number 6 here, I had 2 random samples, A and B, were selected from the same population, and we got a margin of error. We did a 95% confidence interval for each of them. Which of the following could explain why the margin of error of A is greater than the margin of error of B? So why are these different is the question. What's the difference in the spread? So margin of error is talking about the spread. Why is our spread, why is the thing we have to plus and minus, why is this one, the spread is bigger on A than it is B? We did the same confidence interval and I sampled from the same people. So nothing about the population is different. So why is the spread bigger for A? And it starts talking about sample size of A, sample size of B, mean. So remember, when you do sample size, if your sample size is big, your spread, what happens to your spread? So if your sample size is bigger, your spread gets smaller. If I have a sample size that's small, my spread is big. So why would this spread be bigger than this one? It's because this one has a smaller sample size. So if I have a smaller sample size, the spread gets bigger. So that means A had a smaller sample size. So sample size of A less than the sample size of B. That's why, that could be one reason why the spreads were different. So had a bigger, B had a bigger sample size than A. A's sample size was smaller. So the whole idea of these, like bigger the sample size, the smaller the spread. Smaller sample size, bigger spread. So like if I took a sample size of 2 kids from Bryan High, the spread of their heights would be really big compared to like a sample size of 100 kids from Bryan High. Their spread would be much smaller. Okay, moving on. Number 7. Okay, so NYCHA's financial literacy project involved comparing annual sales using the ratio of 1 Canadian dollar to 0.75 US dollars. She converted all sales from the Canadian company into United States dollars. Which of the following values of a statistic in the Canadian dollars be equal to the value of the corresponding statistic in US dollars? So what we're doing is, what she did is she took like Canadian, like let's say that we had Canadian money and she converted it to US money. So which of these numbers is going to be the same? So like the median, let's just come up with a number. Let's say the median she had was like 10. Using this conversion, that would mean that this would be $7.50. So like the median, it's basically saying which one is unaffected by multiplying. Unaffected by multiplying. Okay, so which one is unaffected by multiplying? So the median gets affected, the standard deviation, the mean, the range, all of those change whenever we multiply. So like they get bigger or smaller. In this case, it would be like multiplying by 0.75. So they're all getting smaller. It would be the standardized score. So standardized score is like your z-score. The z-score is the same no matter, that's like the whole idea of doing a z-score, is that it does not get changed. So like a z-score, it converts it to like this 0, negative numbers, positive numbers scale. And a z-score does your value minus the mean divided by standard deviation. So the z-score doesn't get changed because all of these values got converted at the same rate, no matter if they're all Canadian or they're all US. That means it's still going to be the same number. There's still a z-score of 1 or a z-score of 1.25 or whatever we want to say. So the standardized score doesn't have units. It's just like how many standard deviations are you above or below the mean. So it doesn't care if you're in Canadian, Euro, US, like it's just using this formula. So the standardized score. So that one was kind of a tricky one, but if I understand that all of these values do get changed, and then standardized score just means z-score, it is gonna all change together. Yeah. So number eight was an interesting one. So the way these tests work is generally they go like beginning of the year stuff at the beginning and then end of year at the end of the test, and then they mix it. So like number 8 is actually kind of an end of a year question, but they throw it in here at the beginning. So number 8, the manager of a restaurant tracks the type of dinners that customers order. The data from the customers last year have this type of distribution. So 18% beef, 41%, all these percentages is what we had. The manager believes that there might be a change in distribution. We took a sample of 200 orders that were placed last week, and this is what we got out of 200. Okay, assume each order is independent. For which type of dinner is the value of its contribution the appropriate test statistic, the greatest? Okay, so what the heck does this mean? So the appropriate test statistic. So what does that mean? So a test statistic is like a hypothesis test statistic. So it's these things, like a z-score, a t-score, or a chi-squared value. And so it would be like, which one of these is the biggest value? Which one has the biggest z-score, the t-score, or a chi-squared? And so before we do this, we need to decide which one we're actually doing. And so the thing about this one is a t is for means, and we're not talking about means here. We're not talking about like average. Z's are for proportions, which like that's what these are. But a chi-squared is like how well do we fit our expected, which that's what this is. This is what I expected, and here's what I observed last week. And we're asking how well does it fit it. So what we're actually doing here is like which one has the biggest chi-squared value. So like which one of these was farthest off of its expected value. So what you actually do is So like this is my observed, and what I'm gonna make is I'm gonna make like an expected number of if I had a sample size of 200. So what I did is I did like 200 times 18% is I would have expected to have 36 beef dinners. 200 times 41% is I would have expected 82. 200 times 15% is I would have expected 30, and then 40 pork and 12 vegetarian. So we're trying to see which one of these is furthest off in relative terms to the other value. And so we're actually going to do a chi-squared for all of these. We're going to perform a chi-squared test for all 5 of these things. So chi-squared is observed minus expected squared over expected. So I did the test for every single one of these. So I did it for this one. I'll just write it. I did this one. I did the 34 observed minus expected squared over expected. I did 30 minus 40 squared over 40. And then I did this one, 18 minus 12 squared over 12. And so which one had the biggest difference between it? It's actually, so this has a 10 difference and this has a 6. But when you actually do these two values here, this one, the vegetarian, was the greatest difference relatively speaking, because I expected so small and I got a bigger range. So the biggest chi-squared value was this 18 minus 12 over 12 business. So the answer was E, vegetarian. Like it had the greatest chi-squared value. So test statistic, appropriate test statistic is like between these options. And I chose chi-squared because I thought I would have this proportion and I got this. So it involved multiple things, seeing if we would actually get these values. So do my like 5 different outcomes fit what I actually expected? Okay, so that was kind of a tough one doing chi-squared, which chi-squared value. But the main thing there is the thing test statistic. So which test statistic? That just means chi-squared, z-score, t-score, which one of those? Okay, number 9. A company that makes fleece clothing from 2 farms, Northern Farm and Western Farm. So I have X is Northern Farm. So X has a mean of 14.4 and standard deviation 1.3. That's for X. Y is the Western Farm, and Y has a mean of 6.7, standard deviation 0.5. And that's for like, that's the weight produced by a sheep. So this is a sheep from the Northern Farm is typically 14 pounds plus or minus like 1.3 typically. A sheep from the Y farm is typically 6.7 pounds plus or minus 0.5. Okay, it says W is the total weight from 10, so N equals 10 Northern Farms and 15 Western Farms. Which of the following is the standard deviation? Okay, so I want to take 2 different standard deviations and I want to add them together. I have standard deviation of 1.3 and I have a standard deviation of 0.5. All right, and what I want to do is I want to add these two standard deviations together. And so whenever you add standard deviations, it's like a weird number where you can't just add the square roots. You have to square these numbers and then add them together and do the square root. But the tricky thing about it is that I actually have to take into account that I wanted not just one of those, I wanted 10 of these, and I wanted 15 of the western farm. So it's going to be 10 times standard deviation squared plus 15 times that standard deviation squared, then add them together, then do the square root. So when you add standard deviations together, you have to square them and then do the square root. And then the whole reason I did these numbers right here, 10 and 15, is because they wanted 10 from the northern, 15 from the western. So I had to add 10 of those, 15 of those, then add them together. So I had to separate them with those. So this was a common answer. This is for like a hypothesis test. You don't have to square those numbers, is why that term. So that one was another pretty tricky one. You can look at the percentages of correct, and a lot of these answers are like less than 50% of people getting them right for that 2018 year. And so, but just working out using this formula and then adding in this whole it's 10 of these and 15 of those. So they add in trick parts to it. Can you actually know more than just this formula? What if I wanted 10 of those, 15 of this? So yeah, standard deviation, combining standard deviations. I have to do the squared plus the squared, then square root. Okay. Again, the daily videos are great reminders, reviews, and going through stuff. Okay, number 10. According to a report of veterinarians in the U.S., 36.5% of households own a dog, 30.4% own a cat. If one household in the United States is selected at random, what's the probability they will own a dog or a cat? Okay, so this question's kind of weird. So I've got a dog, and then I've got cat. And so it says this entire circle of blue is 36.5, and this entire circle of green is 30.4, and it wants me to know the probability of owning a dog or a cat. And so that would be dog or cat would be me adding all these things up together. The problem is they didn't tell us there's the probability that there's overlap. It's possible to own a dog and a cat. It's possible to own both dog and cat. And so since I don't know, they didn't give me any information. This could be 10%, it could be 30%, I have no idea. And so because I don't know how much this overlap part is, I do not have enough information to determine the probability. I have no idea what that number could be. So I can't just add those two numbers together because I know that there's people who own dogs and cats. So I need to do 30, I need to do 0.36 plus 0.304 minus this number. And I don't know what that number is. I don't know what the overlap is. So I don't have enough information to give an answer there. Okay, so not enough information. All right. Number 11. Okay, reading a box plot, which statement is true? So which statement is a true statement based upon the reading of the box plot? So the number of people surveyed at the more than 4-year college is greater than the number of people surveyed at the high school level. So let me see here. So it says we did a sample of people at each. So it doesn't say the total number. And so from a box plot, like the number of people surveyed, I can't tell how many people are surveyed. I don't know the sample size just from a box plot. That's not what a box plot tells me. So this is not a true statement. I don't know. The proportion of people surveyed from the first quarter to the third quarter at the 4-year college level, so first quarter quartile to third quartile, is less than the respective proportion from the community college. So specifically it says the proportion of people is less than the proportion of people from the community. And so what proportion is in between these two levels? It's 50% of that population, and in between these two, it's 50%. So in between any Q1 and Q3 is 50% of your data. And so the proportion is actually the same. This quartile, the interquartile range of this is bigger than this one, but the proportion is actually the same. So that's a wrong statement. Okay, the interquartile range for the number of visits at the more than 4 college level, so the more than 4 right here, this interquartile range from 1 to 2, so 1, is less than the IQR at the community level. So here's the community level from 1 to 2.5. So yeah, that's 1.5. So is the IQR at this is less than this? That's actually a true statement. The community college is greater than this IQR. Let's just check the others. The maximum number at the community college level right here is greater than the maximum number at the high school. So that's just not true. And the median number at the 4-year college is greater than the median number at the high school. So median right here is not, it's less than that. So I think the real trick one is this right here. They were hoping that you answered B before you got to C. So C is the correct answer, but they wanted you to answer B. They wanted you to answer B, but the correct answer is C. All right. Okay, number 12, for a recent season in college football, the total number of rushing yards for the season is recorded for each running back. The average rushing yards for the season so the average was 790 yards. One running back had, so 790, one running back had 1,637, which is 2.4 standard deviations above the mean. What is the standard deviations for that season? So they wanted you to look at this 2.4 standard deviations above the mean, what that's saying is that was a z-score of 2.42. Standard deviations above the mean. Positive 2.42. So a z-score is written like this. Z equals value minus mean over standard deviation. And so what we have is I have 2.42 equals 1,637 minus 790 divided by standard deviation. So they're asking us to solve for this standard deviation. So if I solve for this, I could multiply by standard deviations on each side. So cross that out. And then that would be divide each side by 2.42. So it would be 1,637 minus 790 over 2.42. Which comes out to like 350. So the whole thing on this one was, could you identify that 2.4 standard deviations above the mean is talking about a z-score, a positive 2.42 is what that was saying. So a z-score of positive 2.42. Alright, so they are tricky. They really want you to be able to show that you fully know these definitions and going through. And so that's why I want to do as many practice tests as possible. And you can look up some more practice tests. They're just online and stuff, so you can see them for yourself too. Okay, let's do a few more here. First year students enrolled at a college were asked whether they play video games, and the responses were which school are they in, so this category, and do they play or do they not play. So two different categories. Of all the students who responded, approximately what proportion responded that they play video games? So of all the students who enrolled in the School of Arts, so how many students enrolled in the School of Arts? That would be, so of all the students who enrolled in the School of Arts, 793, of those, what proportion said they play video games? That would be 347 out of 793, which is C. So specifically here, of all the students enrolled in the School of Arts. So that's why I only care about this number. Of those who enrolled in the School of Arts, what proportion? So the wording on these is super important to get the proportions right. If it said, what proportion of students are in the School of Arts and play video games, that would be 347 out of 1,432. If it said the proportion of students who are in the School of Arts and play video games, that would be this. But this was saying of those, of the School of Arts, how many did it? So that's why it came out this way. Okay, number 14, sampling and experiments. A pharmaceutical company manufactures medicine to reduce pain by migraines. The company is investigating a new medicine is more effective than the current medicine. We did a random sample of 500 who were experiencing migraines, and the participants were randomly assigned into one of two groups. So I had 500 people, and they were randomly assigned into two groups. The first group received the current medication, and the second group received the new. And then they were instructed to take the medicine and rate their pain. After 6 months, they were seen like they compared. So they did the trial and they compared between the results. Which of the following is this study? So is it an experiment, observation, observation? So it's what we did is we assigned, we gave them the current or the new. So it's not observational. We actually gave them the medicine. And then matched pairs is when we use the same person. Same person gets both. And so that's not this case. This was just a straight up, like an experiment where I randomly assigned. Okay. All right, let me take a break while we're changing class periods, and then I'll finish up the rest of the video.